Hi, I'm Paulina Mwakira, and in this demo, we'll be setting up VPC Peering and the AWS Transit Gateway later on. We'll first connect VPCs using peering, hit its limitation, and then move on to Transit Gateway for a scalable solution. So let's dive right in. I'll get started by spinning up my infrastructure a bit quicker using AWS CloudFormation. And then I'll explain what the infrastructure is all about, just setting up the base for now. So let's get started. Quickly create a stack. It's just a stack of my VPC resources. So with new resources, I'm going to choose an existing template, upload a template file, choose my file, which I'll also share. And I want to create multiple VPCs using this file. So I'll just call it Multi-VPC. And you can see as part of the parameters, what I need is my IP address. This is because I'll be just using that as part of setting up my security groups. I want the roles to allow only SSH from my IP. So I'll just search what is my IP. I think it's quicker this way. Here it is with a /32. And go ahead and create my stack. Okay, just taking a look at what is being created for now. This is my basic architecture, which I'm building. So I have 3 VPCs, VPC A, VPC B, and VPC C. In all these VPCs, they are spanning 2 availability zones. So, and they have different CIDR blocks. So you can see VPC A 10.0.0.0/16. This is 10.1.0.0/16 and 10.2.0.0/16. Yep, each VPC has 2 public subnets, spanning multiple availability zones. And you can see in the public subnet, we are placing our NAT gateways for allowing our resources in our private subnet to have access to the internet through the NAT, through the internet gateway. So we have also spin up an EC2 instance in one public subnet, which is in VPCA, that will be just used for management purposes. But what we'll be dealing with is these EC2 instances, which are in the private subnets. So every VPC has an instance in every private subnet. And then that is what we need for now. Later on, we'll be utilizing the transit gateway, and we are going to need this infrastructure where we'll be having the transit gateway in the remaining subnets. This is basically the architecture that is being spun with our CloudFormation template for now. So all the route tables are set, routes to the internet gateway, and then from there, we'll get started with setting up VPC peering. So just to have an overview of what VPC peering is about, now imagine you're an AWS architect and your company you are managing a growing infrastructure. So you basically started with one VPC. Life was good, but then the dev team maybe needed a separate VPC or separate environment. So this is for the dev team. And then maybe the security team came along. Then the database admin, we need a dedicated VPC for a database in this case. Now suddenly you have a mess of VPCs, but they all need to communicate to each other. So what do we do in case communication needs to happen? So the first way to go about it, I call it the quick way, we use VPC peering. And with this VPC peering, this is just a direct link between VPC. So here we are setting up a direct connection between VPC1 and the database subnet in this case. Now, the other way we can go about this is using the transit gateway, which we'll discuss after setting up our VPC peering connection. So here comes a problem. The problem is VPCs are isolated by default, and there is no cross-VPC communication unless we enable it. So if we have an application over here that needs to get information from the database, we can set up that VPC peering connection, which establishes a one-to-one connection between VPCs. One thing is this connection is private, so the traffic never goes through the internet. And another pro is it can work within a specific region or cross-region or cross accounts. So when do we use VPC peering? Very simple use cases where you want to, for example, connect a backend VPC to a database VPC, low latency private communication, and when you need just a few VPCs connection. When do we not use VPC peering? We have more than a few VPCs. If we have 100 VPCs, all these VPCs, remember as I mentioned, this is a one-to-one connection. So I have to set up the peering connection all through, and this becomes messy. And one thing about this is there is not transitive routing within VPCs. And what does this mean? If I have VPC A, B, and C, and VPC A has a peering connection to VPC B, and VPC A has a peering connection to VPC C, that does not mean that B can directly talk to C through that peering connection. If I want VPC B to communicate to VPC C, I also need to set up a direct peering connection between them. So just because A is a friend to C and A is a friend to B does not necessarily mean B is directly a friend to VPC C. Okay, hopefully our infrastructure is all set up by now. And yep, so our architecture is already created, so we can go directly to the demo and start building our peering connection. So if I go to the VPCs and refresh this, so we can see my 3 VPCs are now available, and we want to go ahead and set up our VPC peering connection. So we'll get started with peering VPC A and B. And what you'll notice, just to see our architecture, we also have the EC2 instances in the different private subnets which are set up. If we go to subnets, so just arranging this, yeah. So we can see the VPC A, okay, I needed to load that. So we can see VPC A, private subnets in both availability zone, the public subnets, VPC B, private and public subnet, and the transit gateway subnet as I showed you in the architecture, VPC C, private, public, and the transit gateway subnets. We have the route tables for the different VPCs, just rearranging this. Yeah. So we have VPC A, public, private route tables, B, C, and the transit gateway route tables set up. We have the internet gateways for the 3 VPCs, VPC A, B, and C. And I think everything is set up correctly. We have a couple of instances running. So let's see. We have 4 instances running. And we can see VPC A, public server. We have the VPC B, private server, A, private server, and VPC C, private server in this case. So let's go and quickly start setting up our peering connection. So under VPC, we're going to set up our peering connection. We'll just start with VPC A and B, create a peering connection. So this is VPC A. peering with VPC B. So who is the requester? VPC A wants to peer with VPC B, which is in the same account, my account in this region. VPC B is the acceptor. VPC create peering connection. And that does not mean we are done. So if I want to be a friend to VPC B, I request that connection. VPC B has to accept that friend request. So we'll go to actions, accept that peering connection request, and still we are not done. So the next thing is we have to modify the route tables for both VPCs to ensure traffic is routed. And this is where the complexity comes in. I have to go to VPC A, edit its route tables to say that now any communication going to VPC B should go through this peering connection. I also have to do the same with VPC B. Now, if you have like 100 VPCs, this becomes very difficult to scale and manually manage. I am human and we make some errors. So let's go ahead and modify our route tables, and we'll start with the VPC-A private route table. Here it is. And we see the routes. So it has any traffic going to the internet should go through the NAT gateway, and then we have the local traffic. So I want to edit these routes and add a new route, whereby I'm saying that any traffic going to VPC-B, which has this specific CIDR block, yeah, should go through the peering connection. And which connection? This one, VPC-A to VPC-B, and save changes. Now I have to go to VPC-B again, the route table of VPC-B, private route table, and I am editing the routes, add a new route. Any traffic going to VPC-A, VPC-A was 10.0.0.0/16. That traffic has to go through the peering connection, which is VPC-A to VPC-B. Save these changes and we are set. So let's try make a connection from VPC-A to VPC-C now. So I'll be going through the same process. So VPC-A wants a connection to VPC-C, create peering connection, accept that request since I'm the owner of VPC-C, modify my route tables, back to VPC-A private route table, edit routes, add a route, and now we are up to route 5. Yeah, it can get complicated with time. So VPCC is 10.2.0.0/16. The target going to that traffic has to go through the peering connection, which is VPC-A to C, save changes, and same with VPCC. So VPCC private route table, edit routes, add a new one. Any traffic going to VPC-A should go through the peering connection, which is VPC-A to C. Save changes. All done. So what have we done by now? Back to our architecture. So we have set up a peering connection between VPC-A and B, and the second peering connection between VPC-A and C, and modified our route tables to allow them to communicate to each other. So let's test this. Does it work? So we'll go to the instances that we have available, and I will connect to VPC-A private server. So I'm going to use Session Manager. I set up the roles that enable that communication to go about. And let's see if we can ping the other EC2 instances. Just to have an overview, VPCA, if we look at the networking side of it, so you can see it belongs to VPCA. And then, it has a private IP address of 10.0.1.100, and it belongs to VPCA private subnet in availability zone, UST1A. And just taking a look at the other VPCs, VPCB in this case, private AZ server belongs to VPCB, and that is the VPCB private subnet, also in availability zone 1. There is the private IP address. And then we have VPCC. Yep, let's see. There it's private subnet. If you look at the networking section, oopsies, we can see the VPC ID. It belongs to VPCC, VPCC private subnet, AZ1. Okay, let's just test a connection. So we connected to VPCA. Now let's try to ping the EC2 instance in VPCB. So ping 10.0.0. Okay, the slider of B was 1.1.100. We just want to do a count of 5. And yep, we are getting that traffic back. So let's try also ping the VPCC instance, count of 5 over here. And the traffic is, so that EC2 instance is reachable. Now let's try from VPCB. Connect to this instance in VPCB. Finally, okay. So from VPCB, we know it can communicate with VPCA. So let's ping the instance in VPCA 10.0.100 with a count of 5. Tara, works. But can we ping VPCC? Or can we ping an instance in VPCC? 10.2.1.100 with a count of 5. And 2 hours later. Joking. So we can see, yeah, 5 packets transmitted, 0 received. And why? As we mentioned before, transitive peering is not allowed. Just because VPCA has a peering connection to B and C does not mean VPCB will have a direct peering connection to VPCC. And that wraps up our VPC peering. Hopefully by now you have an idea of how to set that up. Now, in the next section, let's get into transit gateway that will solve this problem of not transitive peering, and the moment we have up to 100 VPCs. Who wants to do all that process anyway? Yep. So on to the next one. Thank you for staying along.